Hydrogen fuel cells run vehicles and other machines by directly converting the chemical energy in hydrogen gas into electrical power. Hydrogen is an abundant fuel source and it can be extracted from water, enabling almost any country to produce it domestically. Hydrogen fuel cell engines can power vehicles or run backup generators for large computer operations. They produce electrical power without any emissions. At the heart of the engine is a stack of super-thin hydrogen fuel cells. The engine's blower pushes in air. The fuel tank then feeds in the hydrogen gas. Hydrogen and oxygen react to create electricity. Each fuel cell is made of 5 parts. On each end, there's a channeled plate, made primarily of carbon, a material which conducts electricity. Hydrogen enters the cell through the first plate, which channels it through the next component, a chemically treated paper, which conducts both gas and electricity. Then the hydrogen enters this membrane, where it splits into protons and electrons. The protons react with the oxygen, producing water. The water passes through another paper to the cell's outer plate, where a pump draws it away. Meanwhile, the electrons travel to the end of the stack of fuel cells to electrical wires. After assembling the stack, technicians compress the fuel cells in a hydraulic press. Compression helps the current flow smoothly from cell to cell. It also presses the rubber gasket around each plate to the adjacent one, sealing the stack so the hydrogen can't leak out. The technicians run a quality control test with nitrogen gas to verify the seal. Before releasing the press, they install high-strength steel rods to bind the compressed cells together. For a stack this size, the rods apply 3 tons of pressure. With the stack now off the press, they hook up an electrical circuit board which monitors the voltage of each fuel cell. After securing the connectors to the stack with an adhesive strip, it's just a matter of connecting one to each fuel cell. They secure that connection with a special type of epoxy which contains silver to conduct electricity. They then mount the circuit board and a plastic cover to protect it. The fuel cell stack is now fully assembled and moves on for testing. The technician mounts it on a test station and connects a hydrogen line, an air line, and a water line for cooling. The testing machine runs a 3-hour automated performance test. Technicians mount the stack onto the engine's structural frame and then install the hydrogen recirculation pump. A water pump is then fitted, which cools the fuel cell by pumping in cool water. They then install the components which supply the hydrogen, stored at high pressure in the fuel tank. And it's that pressure that pushes the gas through the stainless steel fuel lines to the cell. Then the fan that blows outside air into the fuel cell to react with the hydrogen. This filter removes dust and other contaminants drawn in from that fan into the fuel. In the meantime, technicians have assembled the computer that controls the whole engine. They connect the wires from the fan, the pumps and the other engine components to the computer. They connect the fuel cell output wiring, which are the wires that carry the current the fuel cell creates and sends it to whatever vehicle or device the engine is powering. A tiny portion of the cell's output powers the pumps and other engine components. Now fully assembled, the engine undergoes extensive performance and safety testing. Once it passes every test, technicians perform a final visual inspection and then install the sheet metal cover. The hydrogen fuel cell engine is now ready to be delivered to the customer, and installed in the machine it'll be powering. Whether running a vehicle like this forklift or powering computer servers, the only byproduct is waste heat and water, which is why hydrogen power is clean energy. It's that simple. More power to you, I say.